everybody! My name's Laura from Theatre of Science. Are you ready for another interactive science lesson? Today we are learning about the science behind storms, and most of us are I'm in the UK, most of us are in the UK, so the first storm we will look at is thunderstorms. Then we'll get a little bit onto cyclones, and then we'll do story time, and then we'll make our tornado. To make a storm, you need warm air to be on the surface of the planet, and then you need cool air to be above it. And then, like we've seen quite a few times, like in my hot air balloons lesson, because warm air has more energy and the particles are a bit more spread apart than the cold air, the warm air is less dense, so rises up into the cold air. And this is called an updraft. So without further ado, let's make an updraft. So if you've got a jug of water, you can just squeeze a good slug of washing up liquid into your jug, and then get your bowl of cold water. Cool down your glass bottle in the bowl of cold water. So you could put the cold water in and then take it out again. I'm just going to give it a little roll in my cold water here. Catherine, you like the umbrella hat? Yeah, thank you. See, my husband said this was a waste of money in the charity shop. I knew it would come in useful. There we go. It's pretty chilly. And then dunk it into your washing up liquid water mixture so you get a little bubble layer over the whole. There you go. Very technical scientific move, this. I have got one. I'm going to try again because that was like a bit messy. It had lots of little bubbles in it. I kind of want one nice clean bubble. Let's do a bit of popping. Yeah, I've got a little filmy bubble. There we go. So put your hands on the bottle and say, whoa, see, because I've got quite big hands. If there's two of you, both of you put your hands on the bottle. If there's just one of you and your hands are small, maybe you won't see it this dramatically. But what you should see is you get a bubble growing. Let's try that again. My hands are obviously too big. There, are you ready? Ready? Hey! So if you can manage that with your hands, that's pretty cool, isn't it? Blowing a bubble without using your mouth. Try now putting that bottle into your warm water, seeing if you can make your bubble even bigger. So what is happening? If you've already done it, have a think. We talk a lot about air getting warm, don't we, in Theatre of Science, so you should be able to tell me why this bubble is growing. Yeah! Oh, how good is that? So you've just made an updraft, really. What we did is we cooled the bottle down, so that made the air particles slow down and move closer together. So when we made the bottle cold, what we really did is just put lots of air into the bottle. And then we put a little bubbly film over the top. And now what we've done is we've warmed up the air, either with our hands or with the warm water. And what has that done? It's made the air particles there it goes. It's made the air particles inside the bottle get more energy again, and they have pushed up, and we've seen a bubble. So that bubble is like proof that our air was rising. The other thing you need to make a storm is you need moisture in the air. So again, if you've got a bowl of cold water and a bowl of warm water in front of you, have a look at the sides and see if there's a difference. Oh yeah, there's definitely a difference here. So this is my warm bowl. See a difference? Hopefully you can see that there's no water on the side of that bowl, and yet on the cold bowl it's really wet. What's that about? First of all, what's that called? I bet you've heard this word before, you know what that is. What's it called when you get water clinging to the side of something cold like that? You should be able to see something called condensation. But there is no condensation on the warm bowl. What's that about? Well, the air is full of moisture. That's what humidity is. It just means how much moisture, how many water particles are in the air. Water particles in the air, they're a gas, they've got lots of energy, they're whizzing around. So when the particles of water hit the cold bowl, that slows them down and they gather together again, move closer together, because particles of liquid are a lot closer together than particles of air, and go back to being water. Whereas the warm bowl, my warm water is a lot warmer than the air. So if anything, water particles coming near this bowl would just get even more energy and then would go off into the atmosphere again. But this is what happens as our hot air goes up. So we've got our updraft full of water particles being pushed up into the atmosphere, and it meets colder air and it condenses into little drops of water. And then they go even further up and they get colder and colder and colder. And what sort of weather does that make when water particles, water droplets get colder? It makes hail. And that is the really exciting bit, because hail then starts to fall down, and as it falls, it gathers charge. So we talk about this every lesson. Everything in the world is made of particles. Atoms are positive particles with negative particles called electrons whizzing around the outside. If you've seen my electricity lesson or my electricity lesson, you've seen this already. So the hailstones fall, they fall against other particles, and electrons scrape off the other particles and onto the hail. So in the end, you've got hailstones hovering at the bottom of an enormous cloud of water vapour, and they've got all little electrons on them. And then what happens? Again, if you are a theatre of science regular, you know that electrons, they do not like being close to each other. They've all got a negative charge, so they're pushing away from each other, they're repelling each other, just like the same bits of a magnet are. And they zip down to the ground, and that is called lightning. Lightning, obviously incredibly hot. It's like an electric current flowing down from the sky. So air particles get pushed out of the way. Once the lightning has gone down to the ground, these air particles smash back together to make our last ingredient for a storm. What is that? We've got big cumulonimbus clouds of water particles hanging in the air. We've got bolts of lightning. We've got hail. What's the last thing you need? What is created when air particles smash into each other once they've been pushed apart by lightning? Did this just the other lesson. A sound wave, and that is thunder. And that is how a thunderstorm works. Are you ready for your test? If a thunderstorm is really big, then it might start to rotate. That's called a supercell thunderstorm, is a rotate. Sadaf, still fuzzy. What's fuzzy? My face? That might just be my face. So a supercell, you tend to get loads and loads of hail, and we do get those in Britain. Colette saying that I'm fuzzy. Gina's fuzzy. The super fans are saying that I'm fuzzy. Is that better? I'm sweaty. Better? Laggy and fuzzy. This is no good. Oh, that's better. Good. Thank you. All right, so thunderstorms that rotate are called supercell thunderstorms, and they've got mesocyclones inside them, which is a spinning column of air, and a mesocyclone has very low pressure. So let's do like the reverse of that experiment again. This time, put the bottle in the warm water and get it as hot as you can. I'm going to pour some extra warm water onto mine. Can you predict what is going to happen, please? What's going to happen if we get the bottle warm and then we put our bubble over the top of it and then we cool it down? I'm going to make my little bubble again. There we go. Yep, that's it. And then I'm going to put that into my cold water and see what happens. Oh, straight away, can you see that? Yes, Christina, bubble will go back into the bottle. Yeah, exactly. Yeah, and this, what we're seeing now really is air pressure at work. So the first time we did the experiment, the air inside the bottle got warm, pushed against the sides of the bottle, pushed against the bubble and made a bubble because there was more air inside the bottle than there was outside the bottle, and the inside of the bottle was warmer, so the air particles had more energy, so we're pushing. This time, the air outside the bubble is warmer and the air inside the bottle is quite cold. So now we're seeing high pressure air moving into an area of low pressure. So basically, the first time we made the high pressure be inside the bottle and the low pressure be outside the bottle, and the air moved from the high pressure to the low pressure. And this time, we've got more air pressure outside the bottle than inside the bottle. So we're seeing the same again. Air always moves from areas of high pressure to areas of low pressure. And that's what happens with a storm, is you get warm air, which is at high pressure, moving into areas of low pressure. Right, you know what time it is now? Story time. Let's go. And then, Callum, I promise, because this was your whole idea in the first place, we will make our tornado in a bottle. This is the story of Daniel Defoe. Daniel Defoe was born in London in 1660. Now, the 1660s were a very strange time to live in London. When Daniel was 5, 15% of the city died from the Great Plague. And the next year, the Great Fire of London destroyed over 13,000 houses. In fact, in Daniel's neighbourhood, only his house and 2 other houses were left standing, which might be why as an adult he was rather confident. The internet calls him a merchant, poet, journalist, novelist, pamphleteer and spy. And he did write an awful lot. He wrote about politics. He wrote in defence of King William III, who was on the throne. People were making lots of nasty comments about poor William because he was Dutch. So Defoe wrote a reminder that there is no such thing as a purely English person. He said we are all from a mixture. Now, in the early 1700s, Scotland and England were completely separate countries, and Defoe didn't think that was a good idea. He wrote a lot of essays and leaflets saying that the 2 countries should come together and form a union. He used a lot of humour, got into quite a lot of trouble, went to prison, got put in the pillory 3 times, and eventually he went to Glasgow as a spy, writing about what people thought about the union and reporting back to King William. Unfortunately, by all accounts at the time, he was not a very good spy. He had too much swagger. He just loved to boast about and sort of hint at the things that he was doing in coffee shops, so he nearly got caught out a lot of times. However, on the 7th of December, according to some calendars, Defoe was feeling quite calm. He was at home with his family. He looked at his barometer hanging on the wall. A barometer is a piece of equipment that uses liquid metal to measure air pressure. So the higher the mercury in the barometer, the higher the pressure. Later, Defoe wrote that the mercury in his barometer had sunk lower than ever I had observed it. He assumed that his children had been fiddling with it. Little did Defoe know that hours earlier, something that history would call the Great Storm had appeared over Wales. It was moving about 20 metres per second, and it reached south-east England in the middle of the night and struck with a force never heard of before. As Britain slept, the wind lifted and dropped whole chimney stacks. In St James's Park, the storm blew fish out of ponds. And it beat birds to the ground. The storm uprooted thousands of trees. 4,000 mighty oak trees in the New Forest were uprooted. And in Kent, they gave up counting how many trees had fallen down when they got to 17,000. A tornado blew a boat in Kent 250 metres away from the water's edge and onto dry land. Approximately 400... bit of the New Forest there. Approximately 400 windmills were destroyed because the wind made their sails go around so fast that the gears, which were made of wood at the time, rubbed together so much and got so warm that they caught fire and burned down. A cow was blown into the branches of a tree. By all reports, it was impossible to sleep. Whew. The noise of the chimneys of neighbouring houses coming down made the Defoe family scared that their house might collapse. But when they opened their door to try and escape into their garden, what they found was roof tiles soaring through the air and then landing and sticking like 8 inches into the ground. So they decided, actually, we'd probably better stay at home. And you think this is mad? It was even worse at sea. The Eddystone Lighthouse, 120 feet tall, was completely swept away. Now, at this time, Britain was at war with Spain, basically just because we thought Spain had too much money and was getting too big and powerful. So a lot of these battles were fought at sea. And when Daniel Defoe went down to the river in London, the day after the storm, he found 700 ships all piled up in a heap together. They say it cost more to repair the damage from the Great Storm than it did after the Great Fire of London. So what caused this terrible night? Well, the science of weather, which is called meteorology, that didn't really exist in 1703. It's very hard to study storms, like you can't recreate them in a classroom setting. It's unbelievable now, but actually the Great Storm was the first time ever that the weather in Britain had made national news. And how did people explain these storms in the very early 1700s? Can you guess? Well, we've got records from sermons at the time saying that people assumed that God was very angry. So at the time, most Europeans believed that a Christian God used the weather to show when he was really cross. So most people were very happy to accept this explanation. Even Defoe himself thought that the ships being destroyed was God punishing England for its poor performance in the war against Spain. Now actually, of course, we still use the phrase act of God to describe things like storms, but really now we just use it to mean something natural that happened that wasn't anyone's fault. So what actually happened? What's the actual explanation that we believe now? Well, from the 1300s to about the 1850s, the world's temperature dropped by a good couple of degrees. There is actual evidence to suggest that this is because when Christopher Columbus went to America, he brought diseases, and so many people died of diseases that farmland grew trees again, and the extra trees absorbed carbon dioxide and actually reduced global warming. So that's why the Earth's temperature fell. That's one explanation. But whatever the reason, Britain at the time, it could have been the coldest it had ever been for 12,000 years. The day before the Great Storm, snow had fallen. So we've got a lot of people writing diaries saying that snow is falling day and night. And these days, scientists reading these clues think that what happened is that intense, very cold polar air moved in from the south and met tropical air. And as we've seen, when those two things mix, this causes a huge storm. So the big difference in temperature is what caused a particularly deep cyclone with particularly low pressure in the centre. So these days we've got technology that gives us advanced warnings of when storm happens, so we hope that we wouldn't get caught out like that again, but of course in the 1700s they didn't have that. A lot of what we know about the Great Storm comes from Daniel Defoe, because he put an advert in the newspaper asking people from all over the country to send in their stories, and then he put them all together in a book in 1704 called The Storm. And then, as someone's correctly pointed out in the comments actually, quite soon after that, Scotland and England did become a union called the Kingdom of Great Britain, and Defoe calmed down, he stopped getting into trouble, and he wrote Robinson Crusoe, which is a famous novel, which you might have heard of today. I think this is definitely my favourite last scene of any story time so far. What is happening there? Brilliant. So that was quite a Eurocentric story. A lot of people at the time, including Defoe, were saying, were literally saying like, this was the worst storm that has ever happened in the history of the world ever. No human being has ever seen such a terrible storm. Obviously these days we are aware that the rest of the world exists. And of course in other countries they get storms far worse than we get. But I've learned some pretty cool word knowledge just for this lesson. So any spinning weather, any kind of spinning wind with very low pressure is called a cyclone. But sometimes you call them hurricanes or typhoons, depending on where they are in the world. So if they're in America, like they tend to form over the sea, so if they're in the form over the Atlantic Ocean, they're in America, then we call them hurricanes. And I suppose probably most of our news comes from the Americas, so that's probably why you know them as hurricanes. But actually if they form over here, oh, I should say that's just in the northern hemisphere as well. If they form over here, then they're hurricanes. If they form over here, then they're called typhoons. And if they form south of the equator, then they're just called cyclones. Like if you saw the oceans lesson, Pacific, Atlantic, Indian, Southern, Arctic, if they form over the Indian Ocean, it's just a cyclone. But I can hear you cry. What is the difference then, Lara, between a hurricane, a typhoon, a cyclone, and a tornado? The tornado is the thing we're going to make next. Well, they're totally different, really. They're both spinning columns of air, and they've both got low pressure in the middle. But they form in totally different ways. Hurricanes form over very hot oceans and are massive, and they change like everything about the atmosphere. They're like 1,000 wide, and they last for days and days. Whereas tornadoes I think one of the biggest tornadoes we know of was about 1.5 miles across, and they only generally last a couple of minutes. I think it was probably a tornado that swept the cow into the tree. They say there were a couple of tornadoes during the Great Storm in Britain, but we don't tend to get hurricanes because hurricanes are massive and they need really warm seas. So by the time a hurricane gets to Britain, it's slowed down because our seas are very cold. Right. Shall we make a tornado in the bottle? Should we make that the last thing we do? Wind, obviously, invisible. What you actually see when you're seeing a tornado is bits of debris spinning around and dust and stuff. So instead of that, we are using washing up liquid. We've already got washing up liquid stuff in the jug, so just use that. Don't fill it right to the top. This is where if you're using a wine bottle, you're winning because you can probably put a screw cap on. I'm just going to have to hold mine, so please don't do this over your computer. Oh, Magdalena says, what about tornadoes? Where do tornadoes come from? Very good question, thank you. Tornadoes form when like a supercell thunderstorm or any kind of spinning weather just sort of happens to make contact with the ground. I haven't explained that very well, but yeah, tornadoes just sort of sometimes pop out of very big thunderstorms because of the way that the air's behaving. Give it a good swirly swirl and then turn it upside down and have a look and see what you see. Okay, let's go. So yeah, the UK does actually have tornadoes. It has 30 to 50 a year, but they're usually very small. Are you getting anything? I'm not getting anything this time. Maybe I've got too many bubbles. So no bubbles. Yeah, let's try a bit less. Oh, there it is. Oh yeah, can you just see that? Got a tornado! Yay, Rebecca got one. Good. Let's keep going. One tornado in Birmingham caused £40 million worth of damage in 2005. But to my shame, I didn't hear about that. Callum, yours is working. I think I've got too many bubbles now, but I'm going to keep going. It is a bit addictive. Oh, yeah. There it is. Colette says, yours worked. Wine bottle with lid and spin it around by its neck. Adding glitter helps to see it as well. All right. Well, this is why I did it at the end, so you guys can go away and practice, because I wasn't going to tell everyone to bring glitter. That is a super cool activity, which doesn't translate fantastically well on screen, admittedly, but that is awesome. You guys should put some glitter in if you've got some glitter. If you've got 2 bottles, put them together, give it a swirl. Just do it all different ways. I mean, it's pretty grim outside. What else are you doing this afternoon? It's what summer holidays are for, isn't it? Right, that is the end of my Science of Storms lesson. If you haven't liked me on Facebook and followed me on Facebook, then please do so. All the past lessons that we did during lockdown are on YouTube. So if you want to go over there and subscribe and watch my adverts. Anyone's been thinking about downloading a sort of irritating maths app, maybe getting a HelloFresh box, or needs Grammarly, you can go to my YouTube channel because I finally put adverts on. Woo! I passed all their tests. So go and watch all my adverts on YouTube. Look on my Patreon page if you are inspired to support me monetarily. My rainbow glasses that I posted to all my patrons were so popular that I've bought a load more because they're great. So if you haven't got one of those for any reason, if you are supporting me or if you want to sign up on Patreon now, then I will post you some glasses. Yeah, thank you so much for coming. Bye. Sadaf rainbow glasses do rule. Karen, what are you telling me about? I didn't see that. Some sort of special lid by double-edged bottle caps. Are you kidding me? Someone's invented a bottle cap that lets you make a tornado in a jar. Wow. I've seen this done with like big plastic pop bottles, but again, I thought asking you guys to have 2 big empty plastic bottles at short notice was a bit tricky. Yeah, alright, let's do what Dawn's suggesting. This can't possibly go wrong, can it? I'm going to put this empty bottle on top and the full bottle on the bottom and swirl it and then turn it over. If you do this after this lesson, do not do it with glass bottles, please. What do? You've got to swirl it, eh? Oh no! Alright, I'll try that later.